Let's see the question fourth. Now let's move to question fourth, which requires us to calculate classification matrix from a confusion matrix. Uh, a confusion matrix is a table that shows how well a classification model performs. It has four values: true positives, cases when we predicted positive and were correct; false negatives, cases when we predicted negative but should have predicted positive; false positives, cases when we predicted positive but should have predicted negative; and true negatives, cases when we predicted negative but were correct. In our problem, we have TP equals 6, Fn equals 4, Fp equals 2, and Tn equals 8. Total predictions equal 20. Let's see the matrix calculation. Now let's calculate the matrix. Accuracy is the simplest. It's the total number of correct predictions divided by total predictions. So we calculate TP plus Tn divided by total, which is 6, plus 8 divided by 20, giving us 40 divided by 20, which equals 0.7 or 70%. Precision answers the question. When we predict positive, how often are we correct? We calculate TP divided by TP plus FP. Here the calculation you can see, it gives us result as 75%. We call also called sensitivity. Answers of all actual positivity cases, how many did we identify? We calculate TP divided by TP plus N, which is, you can see the calculation, the answer here is 60%. Now let's talk about accuracy. The, let's uh, see some more calculations first. The FO score is the harmonic mean of precision and recall at balanced mode matrix. We calculate 2 times precision times recall divided by precision times recall. The calculation you can see for errors, one type 1 error, also called false positive, is when we incorrectly predict positive. You can see the calculation. We have two of these. Type 2 error, which is specificity answers. So you can also see the calculation of it. Let's move on to accuracy. The importance of precision is and recall. Now, why do precision and recall matter more than accuracy? This is a critical question. Accuracy alone can be very misleading, especially with imbalanced data sets. Let me give you a clear example. Imagine we are building a disease detection model for a rare disease that only 1% of people have. A model that simply predicts no disease for everyone would achieve 90% accuracy, but it would catch zero actual disease cases, which is completely useless. This is why we need precision and recall. Precision tells us whenever model says someone has the disease, how often is it correct? In a disease detection example, precision would be zero, immediately showing the model is useless. Recall tells us of all people who actually have the disease, how many did we identify? Again, recall would be zero, which again shows the model fails. Use precision when false positives are costly. For example, in spam detection, you don't want legitimate emails marked as spam. Use recall when false negatives are dangerous. For example, in disease detection, you don't want to miss actual patients who need treatment. In our confusion matrix example, with 75% precision and 60% recall, we are getting a reasonable balance between not having too many false alarms and catching most true positives. Uh, this brought us to the end of our video, and let's discuss the summary. To summarize part 2, we must split data into training, validation, and test sets to properly evaluate models. Cross validation uses all data multiple times for more robust estimates than simple splitting. The confusion matrix is the foundation of all classification matrix. Accuracy is simple but often misleading. Precision shows correctness of positive predictions. Recall shows ability to find all positive cases. F1 scores balances precision and recall, while type 1 and type 1 2 errors represent false positives and false negatives. Especially how specificity shows ability to identify negative cases correctly. Understanding these metrics is essential for building practical machine learning models. Let's see some of the key points here on your screens. Data set splitting, cross validation, confusion matrix, accuracy, precision, recall, F1 score. So this is the end of the video. In this video, we have discussed question third and question fourth of the assignment, and in the next video, we will discuss question fifth and question sixth. So stay connected for the next video. Thank you for watching the video.